Hi everyone. Our world is changing, and the change is visible everywhere. Cities are growing, more and more goods and people needs to be transported, bringing the traffic infrastructure, environment and pollution to the limits. A transformation of the mobility is needed, who has already started, powered by new technologies and services. The mobility of the future will be personalized, automated, connected, electrified, but there is enough space for software, so also software defined. So welcome to my talk about autonomous mobility of the future and open collaboration. So is this a good idea? I'm Andy, working for Bosch as a business development manager for open source for autonomous driving. I'm with Bosch for around about 24 years, thereof 15 years as embedded software developer in different product areas. Since end of 2016, I am working in the area of autonomous driving, bringing open source into automotive. Talking about software-defined mobility. The software-defined car describes a shift in the automotive industry from hardware-driven development and towards a software-centered approach. In the past, the software in vehicles was a closed system. After serious production, software changes could only be made in workshops. In the future, however, customer benefits will be determined more by over-the-air software functions that can be continuously updated than by mechanical functions, such as new infotainment functions, security patches or monitoring functions. This fundamental shift from a hardware-based to a software-centric wheeled IoT device requires a fundamental rethink to meet customer needs. The software-defined vehicle projects provides a universal end-to-end software platform for seamlessly connecting vehicles to the cloud. The platform is developed in cooperation with some other tech providers, OEMs and Tier 1s, and can integrate the portfolio of coherent software modules either as a complete solution or as individual components into their solutions. The important advantages are a pre-integrated software solution can enable smooth and less complex over-the-air updates, as the software architectures of the vehicle and the cloud seamlessly match. In addition, the software-defined car project will develop new software tools that simplify the process of developing vehicle software and services and thus ensure greater efficiency. Enablement of the possibility of the over-the-air updates over the entire vehicle life cycle significantly shorten innovation cycles and reduce the required development costs. The software-defined car platform provides a modular and seamless end-to-end portfolio, including the required operating model that enables any organization to develop and deploy software applications faster and with less effort. The term software-defined car describes a car containing features and functionalities which are enabled by software, transforming a hardware-based car to a software-centric computing center on wheels. Vehicles today can already have more than 100 electronic control units, a growing array of sensors, cameras, radar and light detection and ranging devices. And of course a lot of software, up to 115 million lines of software code. But there's currently a trend to integrate and centralize software functionalities in high-performance central vehicle computers. So the benefits of software-defined cars are unlocking new safety, comfort and convenience features, receive over-the-air updates, for example security patches, infotainment improvements, monitoring and tuning of core functional capabilities of the vehicle. Send and receive vast amounts of data and from sensors and actuators, getting an insight into every aspect of the vehicle, its performance and its place in the connected ecosystem. This will result in new business models by buying packages from the OEM store. For example, you can order here some extra power for track day or some extra range for longer trips. To build software functionalities, an efficient software development process is needed, with shorter development and deployment cycles. and there are three typical options for software development. So you can develop software completely in-house across most or all domains. You can develop the software in-house for one or two differentiating domains and specify and outsource the development. You can outsource software development and keep feature specification, integration and validation in-house. So here the approach is to create an open technology platform and a community for software-defined vehicle development to accelerate the innovation of automotive-grade in-car software stacks, cloud-based vehicle operation, and a highly integrated development toolchain. Software for the mobility of the future. Looking around what is going on, you may be noticed that open source arrived in automotive now. And that is a real cool thing, because some years ago, open source in automotive was a real no-go. So here you can see some examples. Autonomy's future is open source. The Autoware Foundation open sourced some interfaces and tools. Uber open sourced AVS, an open source standard for autonomous vehicle visualization. Then Calar as an open source simulator. Karma from the US Department for Transportation dealing with vehicle-to-X communication. LG open sourced the simulator for the ROS framework. Tesla published some code for the Model X and Model S. GM Cruise and Uber open sourced the visualization tool. Continental published eCal, an enhanced communication abstraction layer. Audi published an autonomous driving dataset, as well as some libraries for machine learning and their functional engineering platform for simulation and testing. Therefore, we started with OpenADX. OpenADX was launched at the Bosch Connected World in February 2018, but we started beginning of 2017 with the first steps, some workshops and partnering activities. During the conference, Dr. Dirk Hoheisel, former Robert Bosch Group Board of Management, outlined the targets and kicked off the initial testbeds, which were worked on in a hackathon format during the 3 days of the Bosch Connected World. The Bosch Connected World provided a good forum for the kickoff with approximately 3,000 participants from various industries working in high-tech. OpenADX was brought up in several follow-on presentations by other organizations, identifying it as an important step in the use of open source for attacking complex problem areas in the automotive industry. Developing autonomous driving functionalities needs a lot of tools. Often you choose best-in-class tools, which are not designed to work together with other tools from different tool vendors. To make them work together, you have to build some connectors, some new APIs, and every company is doing that by themselves. This costs the industry a lot of time and money. Therefore, we initiated OpenADX to mitigate these problems and to accelerate time to market, share costs and risks, and free up resources to focus on customer needs. By defining an industry-wide accepted AT toolchain with an high interoperability and easy access to establish the base for a reference architecture. We found with the Eclipse Foundation, please do not mix it up with the Eclipse IDE, that's are two different things, a host which supports us. The current members are Microsoft, Bosch, ARM, Denso, AdLink, AVL Iteration, Eclipse Source, Itemis, JSIMS, Science Plus Computing, Siemens, University of Applied Sciences in Dortmund, the Open Robotics and the Autoware Foundation. Our goal is to integrate a range of existing products into the development suite. You can see here the blueprint. We know it is not 100% complete, but it is a good starting point for discussions and agreed by the current members. The color code shows you have many specialized tools from different vendors. Horizontally, you can see toolchain examples from different companies. As companies invested in their toolchain with buying licenses or training of the employees, we do not want to define the one and only toolchain. No. We are focusing on the tool interfaces and the data models to ensure interoperability and exchangeability of the single solutions. We believe an initiative like this should be inclusive, not exclusive. This will ensure transparency and make a complex tool landscape more accessible to enterprise users. OEMs and Tier 1s will benefit from the integration with increased efficiency. Being integrated in a standardized toolchain framework makes the tooling providers more attractive to companies using their products as well. In other words, everyone wins. So with OpenADX, you are able to build your own software development toolchain to build cool products. Here you can see an example with our blueprint, and of course OpenADX came out of the AD development. We have here as an example an AD software stack. From my point of view, a toolchain should be in the cloud to reduce the installation efforts, to reduce access management and so on, so that you can easily start within a short time. The products can consist of available parts which you will find in a marketplace, or you can develop them by yourself, and if you like, you can bring them also to the marketplace as well. The same is valid for the toolchain. From developer's perspective, with over-the-air capabilities, you can shorten the way between development and car, because you are able to access the vehicle directly and get data which you can process in the cloud. Have a look on our vision, which we try to fill with available solution. So currently you see a lot of white spots, but we are trying to fill them. So we have a rolling computing center at the top left, which collects data and bring them via different approaches to the backend. Therefore, you can extract scenarios, you can enrich and map and label the data and bring them to a database. And of course, you can also visualize it there. Use them in the development cycle, simulate the functionalities, check them and homologate the vehicle at the end. With the software stack, you can rely on available hardware architectures and future approaches like RISC-V. Using an open operating system can also lead to a hardware in the cloud approach. On top of the operating system, you can use available software stack parts. Here in this example, you see here some available projects from the ROS framework. You can see here ADX, Cyclone DDS, and other functionalities. Together with other open source initiatives, OpenADX lays the foundation for safety and standardization. The Eclipse Foundation hosts automotive working groups who are dealing with measurement and data handling, OpenMDM, urban traffic simulation with the solution Sumo in Open Mobility, and the virtual simulation OpenPath. There are also some public funded projects out there which we consider for our work, because we do not want to reinvent the wheel a second time or a third time or a fourth time. We will use existing solutions. With App4MC, an exchange platform for timing and performance simulation, Eclipse Cuxa, an automotive platform, and Panorama for design efficiency, there are some more automotive projects available. Working together with some standardization organizations like ASAM or Modelica are also helpful to bring our open solutions forward. With open hardware approaches, so there are a lot of open hardware projects out there like RISC-V, you can design a complete software development kit. Here are our current open source projects. Chloe, a simulation middleware which connects and controls the real simulation engine with the software under test, providing a user interface to see what happens during the simulation and to adjust some simulation parameters or function parameters. Chloe is a kind of abstraction layer which connects the simulation engine, open source or proprietary, with the software you want to test. In this case, we test the AD software stack, which is typically proprietary. In our automotive middleware, we have also an open source plugin, Isorix, which you can use. Isorix is a middleware with a zero-copy shared memory approach, which is optimized for the huge data inter-process communication. Zero copy means we do not copy message data at the beginning of an execution of a function, we handle references. For more information, please have a look into the project descriptions. Here you can see an overview about the hosted Open ADX projects. We are currently hosting 6 projects, 2 for simulation purposes like Chloe and OpenMCX, App for AMC, an exchange platform for timing and performance simulation, a playground is currently under construction, and some projects for communication, especially an OMG DDS standard implementation. So here you can see more information about our simulation middleware Chloe. You have here the project description and also the link to the project itself. Here you can see Chloe in action. We have a proof of concept on Azure with that. So you can see here the input from the simulation engine. You can see here the parameters we visualize. We can adjust for the simulation and of course for the functionalities. And you can see what the simulation is seeing therefore. Here you can see a little bit an overview and more information about ISORIX and the link and how to find everything. So here you can see how ISORIX is working. So you have in the middle a data provider, so to speak. And here's some data subscribers and you can see how it is working. So you have here more or less fixed addresses where you have the data in there, and everyone who wants the data gets the pointers and can get the data out of that, but it's not necessary to copy them into your task. Find here more information about Cyclone DDS. It's a standard-based data sharing technology designed to secure platform-neutral interoperability. Originally IoT focused, but now also for automotive purposes. So it's widely used and in diverse product initiatives used. So here you can find more information on how to find the repositories and so on Cyclone DDS. OpenADX targets the realization of open solutions. With the OpenADX AD portal, we are focusing primarily on autonomous driving, with some toolchain proposals, cookbooks and how-tos still under construction, but a lot of content is still in there. So non-proprietary solutions initiatives can come from anywhere. And we are happy to include them. Do you know the Indy Autonomous Challenge? With a real autonomous race car on the Indianapolis Motor Speedway, we have open ADX technologies on board. So you can here see in a small case our logos. So check out for the Indy Autonomous Challenge. So the final race will be in October 23rd. Check out. Cool thing. So to provide more insights into the work of OpenADX, we are currently developing a program plan with our goals. So a roadmap will also follow. We started to build a co-simulation demonstrator to showcase our work and provide a playground for our solutions. In an early stage, we started to build a workplace based on Eclipse VIA, which is very similar to Visual Studio Code. What do you miss in there? What should we add from your point of view? So please let me know. You can share your solution with me or with us. You can contact me directly or via the OpenADX mailing list. You will get the contact data a little bit later on. To sum up, open source software is gaining traction in the automotive industry. It minimizes dependencies on suppliers, which is highly welcome, increase quality through broad testing, reviews, skilled attention, and broad expertise. It enables risk sharing and cost reduction, and it will be essential to the success of partnerships and consortia. So the future of mobility will be software defined. Open technologies and open source helps to collaborate in a changing automotive market. We invite you, help us to form and shape OpenADX and the future of mobility. Here is a list with useful links about OpenADX and all the projects I mentioned within this presentation and some further material. If you would like to discuss more in detail, so feel free to contact me. Here you can find my contact data. Thank you for having me, and thanks to ARM to give me the opportunity to talk here at the ARM Dev Summit. Thank you so much.